Assalamu alaikum. Welcome to my channel, Jahangir'S Science School. Today I am going to discuss about IGCSE or GCE O Level Physics, Chapter 1, Physical Quantities and Measurement Techniques. First, we have to learn about what is physical quantities. Physical quantities. Physical quantities. Physical quantities, the things which we can measure in this physical world is called physical quantity. That means physical quantities is the things in this physical world which we can quantify by number and unit is called physical quantities. Like mass, length, time, we can quantify this quantity things, physical quantities by number and units. That's why it is called physical quantities. Measurement is the process or method by which we can quantify any physical quantities by number and unit is called measurement. So remember, measurement is a method or technique. Measurement is a method or technique. So first we have to learn about what is physics. Physics is the branch of physical science which deals with study of matter, energy and their interaction between them. So physics হচ্ছে সায়েন্সের এমন একটা ব্রাঞ্চ যেখানে ম্যাটার, এনার্জি এবং তাদের ইন্টারাকশন নিয়ে স্টাডি করা হয়। নাও physical quantities, those things which we can measure, which can be measured in this physical world is called physical quantities. Like length, mass, time, acceleration, momentum is the physical quantities. Non-physical quantities, the things which we can quantify that thing by number and unit is called non-physical quantities. Like emotion, love, affection, patriotism, we cannot quantify them by number. That's why they are non-physical quantities. Non-physical quantities. So physical quantities, all measurable quantities, all measurable thing are called physical quantities. Length, mass, time, temperature are the physical quantities. So physical quantity is a physical property of the matter. What is a physical property? Physical property like length, breadth, height, mass, density. Density is the physical properties. Melting and boiling point is the physical properties. So the physical quantity is a physical property that can be quantified by measurement is called physical quantities. What is measurement? The measurement is the process of quantifying. So process, remember, measurement is a process of quantifying the properties of an object by expressing them in terms of a standard amount, essential amount is called measurement. It's called measurement. So measurement is a method or process. So measurement So measurement is defined as the process of comparison of an unknown quantity with a known or standard quantity. known or standard quantity তার মানেটা কি সে আমি একটা টেবিলের লেন্থ মেজার করতে চাই ফার্স্ট উই হ্যাভ টু standard we need a standard amount or quantity comparing with whom we can measure the length of this object. So measurement is defined as the process of comparison of an unknown quantity with a known or standard quantity. So measurement is the process of quantifying the attribute of an object or phenomenon relative to a standard. So measurement is a process or method of quantifying the properties of an object by expressing them in terms of the standard unit. Now why measurement is necessary? Measurement can be important. Why do you need measurement? We need to measure the concepts in our hypothesis. When we measure those concepts, they become variables. Measurement is important for collecting data. So measurement comes before data collection. What is measurement? So remember, to help make sense of the world around us, to determine the size or amount of something, measurement is necessary for engineering, physics, math, economics, pretty much everything we do every day. So there are two types of physical quantities. One is fundamental quantities, another is derived quantities. Fundamental quantities, so the physical quantities which are independent or neutral, or GCE O Level Physics, Chapter 1, Physical Quantities and Measurement Techniques. First, we have to learn about what is physical quantity. So there are 7 fundamental quantities. Length, mass, time, temperature are the fundamental quantities. Length, mass, time, temperature, electric current, luminous intensity, and amount of substance. Amount of substance. Now we learned about SI base quantities. So base quantities means fundamental quantities. So length is the fundamental quantities. The SI unit, SI means System of International. So System of International in 1600 ফ্রান্সে একটা কনফারেন্সের মাধ্যমে তারা এই 7টা কোয়ান্টিটিকে এসআই দ্যাট মিন্স ইন্টারন্যাশনাল স্ট্যান্ডার্ড ইউনিট হিসাবে কনসিডার করে সো লেন্থ এসআই ইউনিট ইজ মিটার সিম্বল ইজ স্মল এম mass kilogram symbol is kg time is the base quantity or fundamental quantity unit is second symbol is small s electric current এখন কথা হচ্ছে electric current means rate of flow of charge so I equals to q by t that means to measure electric current first we have to measure charge and time then we after dividing charge by time we can calculate electric current. So definition of base unit is so electric current is so not truly fundamental quantity but remember charge equal to current into time. So charge is depend on electric current. So we consider electric current is a fundamental quantity. So charge is the derived quantity. Remember, charge is the derived quantity. Here charge is the derived quantity, and electric current and time both are fundamental quantity. Temperature, thermodynamic temperature, Kelvin is the SI unit and K is the symbol. Amount of substance, mole. If we express the molecular formula of a compound in gram unit, then that amount is known as 1 mole. So 1 mole. Luminous intensity, candela. Candela means luminous intensity, amount of energy, light energy passing per unit time, per unit cross-sectional area is known as luminosity. So luminosity unit is candela, short from CD. Now we study about scalar quantity, scalar and vector quantity. According to the necessity of according to the scalar and vector. Scalar and vector. The physical quantities which have only magnitude, no direction. The physical quantity which have only magnitude, no direction is called scalar quantity. On the other hand, the physical quantity which have both magnitude and direction, is called vector quantity. So the physical quantity which have both magnitude and direction is called vector quantity. So what is the difference between scalar and vector? Scalar and vector quantities. The quantities which does not depend on direction is called a scalar quantity. On the other hand, vector quantities which have two characteristics, magnitude and direction, is called vector quantity. What is the example of scalar and vector? Scalar quantities the physical quantities which have only magnitude, no direction is called scalar, like number 1, mass is a scalar quantity, number 2, length is a scalar quantity, distance is a scalar quantity, number 4, speed is a scalar quantity because speed equal to distance divided by time. So distance divided by time. So that's why speed is a scalar quantity. Remember, density is a scalar quantity because density equal to mass divided by volume. Number 6, remember, related with current, all are scalar quantity like charge, current, potential difference, voltage. Potential difference, alternative name is voltage, potential difference. EMF, electromotive force. Pressure is a scalar quantity. Pressure is a scalar quantity. On the other hand, vector quantity, the physical quantities which have both magnitude and direction. Weight is a vector quantity. Weight. Number 2, displacement is the length covered by in a particular direction is called displacement. So displacement is a vector quantity. Velocity is a vector quantity because velocity equal to displacement by time taken. Displacement by time taken. Moment related with force. So moment equals to force into perpendicular distance. So perpendicular distance. So momentum is a vector. Because the momentum is the product of mass and velocity. All type force is vector quantity. All type force. Work, energy, power, kinetic energy, gravitational potential energy, all are scalar quantity. Remember, kinetic energy, gravitational potential energy. So related to energy, all are scalar quantity. So this is the example of scalar quantity: mass, length, distance, speed, power, energy, work. And vector quantity, displacement, velocity, acceleration, force, weight, friction, momentum, all are vector quantity. So distance, speed, time, mass, temperature, pressure, kinetic energy, gravitational potential energy, work, power, current, potential difference, resistance also is scalar quantity. On the other hand, displacement, velocity, acceleration, force, weight, momentum, all are vector quantity. If you like my video, subscribe my channel and share this video with your friends. Thank you very much watching my video. If you think this video is effective for your study, then share with your friends.